Alright guys, so this is your video for the leading coefficient test for polynomial functions. So on here, this is actually very great if you want to pause the screen and copy this down. This breaks down everything we're going to be talking about. So give it a pause if you need to, if not, here we go. So when you're looking at a polynomial function, so a polynomial function looks like the one up here where you have a whole bunch of terms and they can be to any power. Okay, we do know as we write them, they start with their highest power and then go down when they go towards the right. There's a couple things we need to be able to pull out of each polynomial, and that is going to be the exponent and the leading coefficient. And that should make sense because this is called the leading coefficient test. So the two things that you'll always need to know are the exponent and the leading coefficient. Sometimes we just shorten that to an LC for the leading coefficient. So our leading coefficient test is broken down into two topics. Our first is broken down by the exponent. So we care not necessarily what the exponent is, but whether or not it's even or odd. Okay, so it's kind of like we'll have two options here. So you can either have an even exponent or an odd exponent. So looking at that, you can see, I'm going to zoom this page out a little bit. You can see how we kind of have number one and number two. Number one is for when your exponent is odd. Number two is for when your exponent's even. So let's look at the odd one first. Let's say we've decided that our polynomial has an odd degree. Now we're broken up into two like kind of subcategories, and that depends on your leading coefficient, your A. We know that A does a lot to our functions, right? It can reflect, it can stretch, it can compress. So really thinking about if you're A and you just care about the sign, we only care about if it's being reflected or not. So we care about if our A is positive, so if our leading coefficient is positive, bigger than 0, or if our leading coefficient is negative, less than 0. So far what we've done, we broke it down by deciding that our exponent was odd. Then we look at our leading coefficient. Is it positive or is it negative? So if you can remember the easiest function that has an odd degree, you can remember what's going on here. Okay? So thinking about the easiest function that has an odd degree is a line, right? X to the first, that's an odd number. So when you write that out, if you think of y equals x, that's an odd exponent. Now we know when a is positive, we have a positive slope, right? That's the number in front of x. So this is odd and positive. When it's odd and negative, it's like having a negative slope. So odd and negative, okay? That's the easiest way to break this down and to visualize it. Any other function that has an odd exponent will follow the same properties. So looking at the ends of an odd exponent polynomial, you can see how they're going in opposite directions. So one thing I always like to remember is that odd equals opposite. Okay, so odd functions, their ends are going in opposite directions. So for instance, on the left-hand side, we have an exponent that is odd, because that's where we're at right now, and the left graph is telling us that it's a positive leading coefficient. So it's kind of like if it was a line that had a positive slope. Which way would the ends be facing or pointing? So we would say, we could break this down a little bit easier too. The way you can write it for me, if you wanted to write LHS for left-hand side, you can say that that's going to the negative infinity, and the right hand side, as it's going to the right, it's going towards positive infinity because it's going up and it's never going to end. Okay, so LHS is left hand side, RHS right hand side. Now you can see the same thing for the right hand graph. It's an odd exponent, and we can always tell that also by the ends, right? They're going in opposite directions, and it must have been flipped over, right? It's the opposite of what we started with. When we're our left-hand side, that one's going up. So our left-hand side is going to infinity, and our right-hand side is going to negative infinity. Think about a line that has a negative slope. It's going up on the left and down on the right. So now let's talk about our other option if our exponent was even. So if you look at the even graphs, we're broken down into two subcategories again. We have an even exponent where our leading coefficient is positive. So like when a is positive. And we have our leading coefficient is negative. So again, that a is still doing the same thing here. It's either facing up or down. So our easiest function that has an even exponent would be f of x equals x squared, right? A parabola. And we know that if a was positive, our parabola is facing up. And if a was negative, down like a frown. Okay? So that's something you already know. So you already kind of know this rule here. You already know the leading coefficient test. If it's even and has a positive leading coefficient, both ends are going up to infinity. So you could write that as like LHS to infinity and RHS to infinity. Now, if a was negative, we know the negative flips it over. Now it's down like a frown, and we could say LHS is going to negative infinity, and the RHS is going to negative infinity. Now you'll notice one of the major differences between odd and even, we said earlier that odd was opposite. Even, they have the same end behavior. So even has the same ends. Oops, forgot the word has. So even has the same ends. Okay? So they either both go up or they both go down, but they're not going to be opposite. So let's kind of like sum up what we were talking about here before we apply the test. Two examples I have for you. My first one, my directions are asking me to describe the right hand and left hand behavior. So I know I need to look at two things. I need to look at the degree and the a. So looking at our example a here, my degree is 3, which is odd, and my a is -1, which is negative. So I know this is going to be like any odd function that has a negative in the front. So for instance, if I think of a line that has a negative in the front, it has a negative slope, and that's what I can visualize here. So I know my left hand, if I look at my visualization, it's going to positive infinity, it's pointing up. My right hand side is pointing down, so to negative infinity. And that's a perfect answer right there. You don't need to do anything else other than just reference the degree and the leading coefficient. So let's look at this last example. So my degree is 4, which is even. My a is a 1, which is positive. So that means I just need to think about the easiest even degreed function that has a positive a. So if I just think about my parabola, when it's positive, it's facing up, it's happy, it's smiling. So that means my ends are both pointing towards positive infinity. So my left-hand side is to infinity. My right-hand side is also going to infinity. So you'll notice again, the evens are going to the same directions. They're both going towards infinity. The odds are opposite. That's a good way you can check your work along the way to make sure that you're not entering the wrong answers. So we said that first thing we had to do, check degree. And that meant, is it even or odd? Then, after you determine the degree, you need to determine sign of a, right? If it's positive or negative. Those are the two things you need to reference. So first the degree, then your a. So let's look at the